Hello! In this video tutorial, we will review the process for creating a custom layer-based wall in Vertex. I will be demonstrating the process using the steel version, but the process is the same in both the steel and wood versions of Vertex BD. The wall libraries will differ, but their structure within Vertex is identical. Different parts make up a layer-based wall. Not all of them are necessary when adding a new wall type, but I'll cover each part in the video to give you an understanding of how they all work together. Let's review what a layer-based wall is comprised of. I have an example of a steel wall on my screen. Double-click on the wall to bring up the wall properties. The wall is an exterior-bearing wall with a 5.5-inch steel frame. Its type is found under the C-channel library, S550-162-54cc exterior-bearing wall type. A wall type also includes other customizable components such as wall layers and wall frame tools. A wall type is defined as a style of a wall. For example, a wall type can be a brick wall with layers such as drywall, sheathing, and framing. Another type could be a wall with vertical or horizontal siding that also includes layers that make up the wall type. Wall layers are materials that are part of a wall type that are used to create the wall style. Wall layers are displayed in the Wall Properties window under the Layers section. In this example, this wall type includes siding, sheathing, frame, and a drywall layer. When building a new wall type, new layers can be inserted into the inside or outside of a selected layer. Layers can also be split to add different materials to specific heights of a wall. They can also be deleted and rearranged by moving layers up or down. Some wall layers have the framing tools associated with them, such as a frame layer. Framing tools are rules that control how materials are handled for the specific wall layer. Examples of some of the settings can be stud spacing, specifying different framing materials for different parts of the wall, and setting specific framing details. Let's open the framing tool for the 5.5-inch steel framing layer. Select the frame layer, right mouse click, and bring up the context menu. Select Framing Tools. The assigned framing tool is located under the System CC Wall Framing Tool Library. Other available framing tools are listed under the Tool field. A number of rules can be set in the framing tool, such as exterior and interior corner details, bracing material, track materials, and stud spacing. Under Openings, you can set the header detail materials for sills, jambs, and kings. There are also NC tooling settings for adding service holes and other settings. Under the Parameters section, you can control the settings to display how the wall is represented in 2D, like changing the line types and color fields for wall layers. Let's take a look at where the system wall libraries are stored within Vertex. These are default libraries that ship with Vertex. It is important to note that system libraries cannot be directly modified. To create a custom wall, new custom wall libraries must be created under the custom side of Vertex. We will discuss how to create custom wall libraries as we continue in this video. There are libraries for each of the three wall components: wall types, wall layers, and wall frame tools. To view the libraries, go to System Libraries to bring up the Libraries browser. Under Libraries, there are three library groups. System Libraries. These are the libraries that ship with Vertex and cannot be directly modified. Custom Libraries. This is where Vertex BD customizations are stored. When we start creating our custom wall, our wall libraries will be stored under this category. Customizations stored here are available for new buildings. Building Libraries. Customizations stored here only apply to the current building. They will not be available for new buildings. The system wall libraries are stored under the System Libraries Architectural Tools. The C-channel wall types are found under Walls C-channel library. There are also other wall libraries for standard exterior and interior walls. The code for each wall type is displayed in the browser. The code indicates the type of framing materials used. In this example, the code includes the prefix EBW, which stands for Exterior Bearing Wall, along with the default material profile assigned in the framing. There's also a description of the wall type. The wall layers are located under the System Library's Architectural Tools, Wall Layers, Wall Layer Library. Here you will find a long list of wall layers that can be applied to your custom walls. Similar to wall types, the browser displays the code for each layer along with the description of the layer material. The wall frame tools are stored under the System Libraries, Framing Tools, Wall Frame Tools, in this case the CC Wall Framing Library. The browser displays the code for each wall frame tool. Similar to the wall type library, the code also includes information on the type of framing the tool applies to. The code for the wall frame tool uses a prefix EBF in the code, which stands for Exterior Bearing Frame. The wall libraries in the wood version are similar to the steel version of Vertex BD. However, the structure of the wall codes between the steel and wood versions is different. The system wall libraries are stored under the System Libraries Architectural Tools. The wall types are found under Walls, with libraries for both exterior and interior walls. The wall layers are located under the System Libraries Architectural Tools, Wall Layers, Wall Layer Library, similar to the steel version. The wall frame tools in the wood version are stored under the System Libraries Framing Tools, Wall Frame Tools, Wall Framing Library. Let's start by creating a new wall type first. It is not necessary to create a new wall layer or wall frame tool if there are system versions that exist and apply to your new custom wall. For this tutorial, we will cover the process for creating each type. As mentioned earlier, before creating a custom wall type, layer, or frame tool, a custom library must exist or must be created first if one does not exist. There are two ways to create a wall type library. Go to System, Walls. In the Wall Library window, select the library in the upper left panel and right mouse click. Select Create a new library. When filling in the library name, do not use a space or invalid characters such as a $, asterisk, etc. You can assign the priority in which to list the new library. A 0 will put it at the top of the list. As you can see, the new wall library has been added to the top of the list. Note that this is an empty library and no wall type has been added yet. The second option will copy an existing wall type to a new or existing library. To view the libraries, go to System Libraries to bring up the Libraries browser. Go to System Libraries, Architectural Tools, Walls. Select a wall library. Select an existing wall type and right mouse click. If you already have an existing custom library, select Copy from the System Wall Library and then search for your custom wall library to paste it to. Select Create New Custom Library if this is your first custom wall type, or if you want to create a new custom library for organizational purposes. Or select Create New Building Library if this new wall type is only going to be used in the current building. I'll select Create New Custom Library to add a new custom library. For the library description, I will keep it simple and just add CUS for custom to the current name. A new custom wall library has been added under Custom Libraries, Architectural Tools, Walls, CUS C-Channel Wall Library. The custom wall library is a copy of the system wall library, except for the description that was assigned. Items listed under custom libraries can be edited, while items under the system libraries cannot be edited. This is why they need to be copied first. The wall type in the new library is an exact copy of the one in the system library. However, we can now edit this wall type to suit our needs. To edit the wall type, select it and right mouse click. Select Properties. In the Properties window, our copied wall type icon is shown in the lower left pane, and the custom wall library is listed in the upper left pane. The layers that make up the wall type are listed under the Layers section. The first item to address is changing the code and description of the copied wall type. Select the wall type icon in the lower left pane and right mouse click. Then select Properties. The code needs to be something unique. I'll remove the CC and add STHS for stone and horizontal siding. I'll change the description field. My new wall type will have a stone wainscot with 8-inch horizontal siding. I'll change the description to exterior stone with 8-inch horizontal siding. You'll notice that the wall type icon in the lower left pane is missing. It will update after reopening the Properties window. We now have a new custom wall type. Though we still have some changes to make to the layers, we will come back to the wall type, edit the layers, and apply a new wall frame tool after we create the other items. Next, let's create a new wall frame tool. This step is not necessary if a wall frame tool that meets your needs exists in the system library. You can apply the tool set to the frame layer. For training purposes, we will create a new custom wall frame tool. Go to System Libraries, Frame Tools, Wall Frame Tools, and select the C-Channel Wall Framing Library. Scroll down and select the 5.5-inch steel frame tool. I'll make a copy of the EBF 550S 162/54cc wall frame tool. Select the framing tool, right mouse click, and select Copy to a new custom library. For the library description, I will just add a CUS for custom to the current name. Similar to before, a new custom library is added under the Custom Libraries section. The Wall Frame Tool library is created under Custom Libraries, Framing Tools, Wall Frame Tools, CUS/CC Wall Framing. A duplicate of the Wall Framing tool is saved in the New Wall Frames Tools library. To edit the copied wall frame tool, select the tool, right mouse click, and select Properties. First, we need to change the framing name or code. I'll replace the CC suffix with CUS for custom. You can edit the code to your liking as long as it is unique and makes sense to you. Edit the wall framing attributes to customize the framing to your needs. I'll make some minor changes to the wall frame tool. I'll change the exterior and interior corner type details to flat. I will change the backer for T intersections to the L backer BLB detail. I'll leave the track material as is, but change the stud spacing to 16 inches for 60 inches on center. Under the Openings tab, you can modify the header details and change materials to the various opening parts. I'll change the header detail for header number 2. I will assign the box header details dbox. I'll also make a change to the header detail for header number 3. I'll assign the CCC header detail D3CH. I'll change the quantity of jams to 2 for both header number 2 and header number 3. And I'll leave the other settings as is, and select OK to close the window. We now have a custom wall frame tool that can be applied to our custom wall type. Next, we're going to add a new layer. This is not a necessary step if there is an existing layer or material type. In this exercise, we're going to take the process a little further. Let's create a layer for a made-up manufacturer's sheathing panel. Let's say there's a new sheathing panel from company ABC that we want to add to our Vertex library. The simplest method for adding a new layer is to create it by copying a similar existing layer and then editing it to what we need. Go to the System Libraries, Architectural Tools, Wall Layers, Wall Layer Library. Scroll down until you find a layer that is similar to the layer you need. I will scroll down and select the SH_W_DG12_48 for the dense glass half-inch 4x8 sheathing layer. Right mouse click and you will get the same 3 options to copy the wall layer. Select Copy to New Custom Library. For the library description, assign any name you wish. I will keep it simple and add the CUS for custom to the current name. Similar to before, When we created a copy of wall type, a new custom layer library was added under the custom libraries. The layer library is under Architectural Tools, Wall Layers, CUS Wall Layer Library. An exact duplicate of the dense glass 1/2" 4x8 sheathing layer is saved in the new layer library. Now we can go ahead and edit the layer material in the custom library. Select the layer, right mouse click and select Properties. Change the description to describe the new layer. I'll change the description to panel ABC 1/2" by 4 foot by 8 foot. Under the code field, we need to change the code to a unique value. I'll change the layer code to SH for sheet, _W for walls, _ABC 12, 12 stands for the 1/2", _48 for 4x8. Leave the settings under the Line Properties tab as is. Under the Surface Parameter tab, we will create a new texture or color and apply it under the Surface Property field. We can come back and change this field after we create the new texture or color map. I will cover this later as we progress in the video. Leave the Fill and IFC tab settings as is. We have now added a new wall layer for our new sheathing panel, panel ABC. Now that we have a wall layer for our new sheathing panel from company ABC, we need to create the sheathing structural sheet or material for panel ABC, which is a 1/2" thick 4x8 sheet. As we have done with the other parts of the wall, we will take an existing material in Vertex and make a copy for editing. Structural sheets are located under the System Libraries, Materials, Structural Sheets folder. We can use any of the sheets with similar dimensions. I'll go to the Plasterboards GP folder and copy the 1/2" 4x8 dense glass material. Select the sheathing material, right mouse click and select Copy to a new custom library. For the library description, I will assign it Panel ABC. Next, edit the custom sheet located under Custom Libraries, Materials, Structural Sheets, Panel ABC folder. Select the sheet and right mouse click and select Properties. Leave the order number as is. The order number is used for organizing items, but since we only have one item in the folder, it does not need to be changed. Under the Page 1 tab, change the description field. I will change it to Wall, 1/2" 4 foot by 8 foot panel ABC. The material code is the same code we assigned the new sheathing layer. Change the sheet code to a unique code. I will change it to panel ABC _12 at 4x8. The width, length, and thickness fields match our sheet dimensions, so they don't require any updating. But this is where the sheet size can be modified if needed. Under the Page 2 tab, we will come back to the Surface Property settings and change it after we create a texture color map for our new panel. Change the weight and volume of the material under the Page 3 tab. Leave the settings under the Page 4 tab as is. In this video, we will cover the steps for creating and assigning a material a new color texture or color map. This is not necessary if a texture color map exists that can apply to the new material. For example, if you need a texture that looks like OSB material, an OSB texture already exists in Vertex. You would not have to create it, just assign it to your new material. In this exercise, we'll create a new texture color map, specifically for our panel ABC. To add a new rendering texture, go to the System Rendering Textures, select Rendering Texture Mapping, all custom changes included. This will list all the textures that are available in Vertex BD. In the Rendering Texture Mapping window, scroll down until we find the Exterior Wall Dense Glass Sheathing Texture Map. The code for the texture is wall-e.sht.dg. We could copy another texture map or just assign the existing map to the new ABC panel, but for this exercise, we'll copy and edit a texture map specifically for our new panel. Select the texture map and right mouse click. Next, select Copy Row to make a copy of the texture. The blue colored entry is a copied texture map. We need to modify the category code to something unique. We'll keep it simple and just change DG to ABC at the end. The code will be wall-e.sht.abc. Next, change the description. Change it to exterior wall panel ABC. To assign a new color or texture to the new material, select the material field and then select the Browser button. The browser opens a library of all the available materials and textures that can be applied. If you want to apply a texture to the sheet material, the textures can be found under the Construction Sheets library. Here you will find the different texture maps that can be applied to a structural sheet. For our exercise, we will assign a solid color to the new panel. Scroll down to the Paint's Basic Colors folder. Over the right pane, double-click the color Semi-Matte Paint. In the Edit Rendering Material dialog, you can assign the texture map color by either selecting a color in the palette or selecting a color from the color chart. To assign a color from the color palette, select a basic color or enter the RGB values if you have those. We will assign a color chart color to the panel. In the browser, under the Color Semi-Matte General folder, there are different colors available to select from. I'll scroll down until I find the light red 1 color for the panel. Select OK to close the Editing Rendering Material window and the Texture Mapping window. Now that we've created a new color texture, we need to assign it to our structural sheet and new layer. Go to the System Libraries. In the browser, go to Custom Libraries Materials, Structural Sheets, Panel ABC Library. Select the Panel ABC sheet we created earlier. Double-click to open the layer properties, or select it, and right-mouse click and select Properties. Under the Page 2 tab, change the Surface Prop field. Change it to our new texture color map, wall-e.sht.abc. Select OK to close the window. Next, let's do the same to the panel layer we created. In the browser, go to the Custom Libraries, Architectural Tools, Wall Layers, CUS Wall Layer Library. Select the custom layer we created earlier. Now double-click to open the layer properties or select it and right-mouse click and select Properties. Change the Surface Property field to the new Texture Color Map. Select the field and scroll down until you find the new color map. Select OK to close the window. Now we can apply the new layer, framing tool, and custom sheathing material to our new wall type. Proceed to editing the wall layers to create the desired wall type. Go to Custom Libraries, Architectural Tools, Walls, CUS Wall Layer Library. Select our wall type, right mouse click, and select Properties to access the wall layers. In the upper left pane, go to the Custom Wall Library, Exterior Bearing 550. Select the wall type in the lower left pane. On the siding layer, let's change the horizontal 6-inch siding material to 8-inch horizontal siding. Select the siding material and then select the drop-down field and select the 8-inch horizontal siding. Now let's change the material on the sheathing layer. We will apply the new panel ABC sheathing to our wall type. Select the dense glass material in the drop-down field. Scroll to the top of the list and select panel ABC sheathing. Any custom materials are added to the top of the list. Similar to frame layers, sheathing layers also have tools or rules that apply to the sheathing. A prompt asking the user to load the framing tool from the library, noting that the current tool will be overwritten. Selecting yes will overwrite the current tool for the layer. Selecting no will apply the existing tool to the new sheathing. We did not create a custom tool for the sheathing. Select yes to overwrite the existing sheathing tool. To view the sheathing tool, right mouse click on the sheathing material and select Framing Tool. This tool is located under the Wall Sheathing Methods tool library, and the tool uses the Route Openings tool. The tool controls how sheathing openings are handled, layout direction, rotation of sheathing, and the type of sheet material. However, we did create a custom wall frame tool, so let's apply it to the framing layer. Select the material field for the frame layer, right mouse click and select Framing Tools. The current tool applied is a default system framing tool under the CC Wall Framing Tool library. We're going to apply a custom wall frame tool to the framing layer. Select the field under the Tool Library column. Select Custom Library CUSCC Wall Framing. Over to the right under the Tool column, click the drop-down field and select our custom framing tool, the tool ending with CUS. Notice that you cannot edit the framing tool when it is part of the layer. To edit the tool, you would need to go back to the Custom Frame Tool Library, open the Frame tool, and make the changes there. As you can see, we have the flat corner detail types, stud spacing 60 inches on center, and our opening framing adjustments that we made in our custom wall frame tool. As you can see in the 3D view, our wall looks a little plain. Let's customize it a bit more. For this wall, let's split the siding layer into two sections. We will change the bottom section to a stone veneer and keep the top section as an 8-inch horizontal siding. Select the siding layer, right mouse click and select Split to split the siding layer into two sections. Now that we have split the siding layer, the next step is to adjust the bottom height and top heights of the layers. Scroll the layer panel over to see the layer bottom and top height fields. Edit the bottom height field for the lowest siding layer. We will change this layer to the stone veneer. The bottom height is negative 10.75 inches. This value represents the layer extending down to cover the floor framing and floor sheathing. In this example, we have a floor system that is 10 3/4 inches deep in total. Next, change the top height to 36 inches. The stone veneer will extend 36 inches above the floor level. Now let's change the siding to stone. Select the stone field. Scroll down until you find the stone material. Now that we have the stone veneer height set, we need to adjust the height for the siding layer. Change the siding layer bottom height to 36 inches. The siding will start where the stone veneer ends. Change the top height to match the wall framing height. For this wall, the height is 120 inches. Rotate the 3D model to see a preview of the wall type. Select OK to close and apply the changes. I'll delete my default wall and add a few walls with the new wall type. Go to the Modeling tab and select Walls. The new wall type is under the CUSCC Wall Library. You can see the new wall type in the lower left pane and the layers that are part of the wall type. I'll draw a few walls and add a window and a door. Switch to the 3D view to see the new walls with the stone veneer. If I select the siding layer and extend that down, you can see our new panel ABC behind the siding layer. We assign the material a light red color. I'll extend the siding back to the top of the wall. Now switch back to 2D and generate the wall framing. Go to Wall, Generate Panels. Select all the wall panels and generate the parts for the walls. Next, let's generate the wall panel drawings. Select the panel ID, right mouse click, and select Create Panel Drawings. Next, select the panel drawing template. Zoom in on the sheet schedule. As you can see, the material listed on the sheet schedule is our new sheathing panel. The wall framing around the openings are built from the wall framing rules that we set up in our custom wall framing tool. To view the framing, switch to the Framing View mode. If new items need to be included on material reports, the materials need to be added to the material registry in Vertex. To access the material register, under the Systems menu, select BOM. Next, select Material Register. For example, we created a new sheathing panel. We need to assign a code in the material registry for the sheathing itself. And we also need to create a sheathing pack code for the new material. A material pack is a package of materials that are needed or used when calculating the amount of material. For example, here's a 1/2-inch gypsum wall sheathing pack. The code for the drywall pack is slightly different from the code assigned to the drywall material in the registry. Packs are categorized according to the material type pack, and their level is set to pack. The lower pane displays the materials that are in the pack and calculated when determining the amount of material, in this case drywall. Under the code column, we have all the materials in the pack: the drywall, joint compound, joint tape, primer, and screws. The optional quantity is a factor that is used in the formula when determining the amount of material. For example, the drywall sheet is a 4x8, which is 32 square feet. The op quantity is set to 1/32. The rule is the formula applied for determining the amount of material. Wall items typically use the number 3 rule. To view the rule, select the Rule button. Rule 3 includes the value of parameter 3 in the calculation. Parameter 3 is area. The formula is quantity times optional quantity times area, or parameter 3. Other material types may use a different rule or formula. Since we need to create material codes for both the sheathing and sheathing pack, click on the category filter and select sheathing and sheathing pack categories. Select OK, and only those two categories are displayed in the material registry. We will make a copy of an existing sheathing material and select the 1/2-inch 4x8 dense glass material. We will use this one since it closely resembles our new sheathing material, but any other similar material would work. Select the material, right mouse click, select Copy Row from the context menu. You can also add a new row and delete a row if needed. The copied material is displayed in a blue font. Since the material code needs to be unique, the code is changed to a default value. Let's change the code so it better describes the material. Maintain the same format as the other codes. Use SH for sheet. Use an underscore. Spaces cannot be used in the code name. Enter ABC to indicate our new ABC sheathing panel. 12 represents the 1/2-inch panel thickness. Use an underscore again to separate the sheathing panel size. And enter 48 to enter a 4x8 sheet size. Next, change the description and add the new panel name, Panel ABC. Don't change the category and level fields, leave those as is. Since there is a SKU number, change the SKU to suit your needs. I'll replace the DG with ABC. For the other tabs, leave them as is. Another method for copying materials is to use the Copy button. The benefit of using the Copy button for material packs is it copies both the pack and the nested pack materials. Select the material to copy. Next, select the Copy button. In the Create New Row dialog, enter the code for the new material and select OK. The new material is added to the end of the material register list. As shown earlier, edit the description and the SKU number if applicable. Adding a material pack is similar to adding a material except for a couple of additional steps. Scroll down until you find a material pack that closely resembles the type of pack we need to add. I'll use the 1/2-inch 4x8 dense glass wall sheathing pack. The material with the pack is listed under the lower window pane. 1/2-inch dense glass sheathing is listed here. To copy the material pack, select 4x8 dense glass 1/2-inch wall sheathing pack and select the Copy button. For the pack code, we need to apply the code we assigned to the Panel ABC material layer earlier in the process. That code was sh_w_abc12_48. Note the sheathing material code cannot be the same as the sheathing pack code. They should be slightly different. The new material pack is added to the end of the material register list. Edit the description of the material pack to reflect the new pack. I'll change it to 4x8 panel ABC 1/2-inch wall sheathing. Next, we need to change the dense glass material located in the lower pane. Change the material to the ABC panel material we created earlier. That was sh_abc12 for 1/2-inch _48 for 4x8 sheet. Edit the material description. I'll change it to 1/2-inch 4x8 panel ABC. Leave the option quantity to 1/32, which represents 32 square feet of a 4x8 sheet. We will leave the rule to rule number 3. To access the rules, select the Rule button. I'll select Rule 3 and select Yes to apply it to the material. Leave the use as walls. I'll switch back to the Architectural 2D view. Go to the Output tab and select Collect to collect materials. Since I only have walls on the first level, I'll select the first level wall framing and wall layout modeling pairs. Select OK. The next window displays all the materials collected from the model pairs. Select OK to close the window. Next, we will create a report. Select Report in the Output tab. I'll select the General Bill of Materials report. The next window displays all the collected materials that will be on the report. Select OK to generate the report. Scroll down to find our new 1/2-inch panel ABC. The report indicates we need 14 sheathing panels of our new sheathing material. Follow these steps to add any materials to BD. Depending on the type of material, some steps may not be required, or they may be slightly different. It just depends on the material type. That concludes the video on creating custom layer-based walls. View our other videos to learn more about Vertex BD.